Hello, welcome everyone. I'd like to introduce Ben Smith of Lunar Homestead.
Yeah, thanks, Jay. So I'm Ben Smith. I'm owner of Lunar Homestead. Lunar Homestead's mission is to develop the technology and techniques needed for permanent lunar settlement. And fortunately, a lot of that tech can be modified for Martian settlement as well. So that's what I'm going to talk about. And today I'm going to talk about my SPORE concept idea. I'm currently working on SPORE for the lunar environment, but I modified this presentation a bit for Mars. One of the main advantages of SPORE is that it can be used in many different environments. And I'm not a Mars guy, so let me know if I missed something or got something wrong. So first, let's go over some of the challenges that SPORE was created to solve. The Martian surface, like the moon, is a challenging environment to operate in. Current plans involve mining and building on the Martian regolith, and this has proven to be difficult and expensive to engineer for. Most of you know how difficult and dangerous the lunar regolith dust is. Martian dust probably won't be quite as big of a challenge as lunar dust, but it's still a significant threat. The Mars Pathfinder wheel abrasion experiment showed that Martian dust is very small. It's got a grain diameter of less than 36 microns, and it's electrostatically charged. Now, if it's anything like lunar dust, that means it's going to get everywhere and stick tenaciously to most surfaces. It'll also probably get ground into most fabrics. This stuff is going to be a cleaning nightmare for habitats. And the Martian dust is also pretty toxic. It contains high concentrations of toxic chemicals such as calcium chloride. And it's not just the dust kicked up from surface operations that are going to be a concern. Planet-wide dust storms will also add to the challenge. But the plus side is that Martian dust doesn't seem to be as sharp or destructive as its lunar counterpart, but it's definitely not something you want inside your habitats. The radiation environment on the Martian surface is slightly less hazardous than on the lunar surface, but it's still plenty dangerous. Like Moon, Mars lacks a protective magnetic shield, and the thin Martian atmosphere helps somewhat, but not much. The Mars Odyssey spacecraft clocked the radiation as 2.5 times higher than what astronauts get on the International Space Station, which is about 8 rads per year, not counting solar events. Now compare that to the 0.62 rads per year that the average person on Earth receives. So protecting settlers from radiation has to be a primary concern. Unlike Luna's near vacuum, Mars does have an atmosphere. However, it's less than 1% of Earth's atmospheric pressure and toxic to humans. For our purposes, if you have to wear a spacesuit to go outside, it's effectively a vacuum. And I haven't looked into whether organic material volatilization, lubricant sublimation, vacuum welding, or heat rejection are as challenging on Mars as on Luna, but I figure there's still going to be significant issues. I'm sure someone will let me know if I'm wrong. The Martian thermal environment is more forgiving than Luna, but it's still challenging. The actual recorded values vary from site to site, but according to one NASA fact sheet, they range from negative 89 degrees Celsius to 31 degrees Celsius, with an average of 63 degrees Celsius. That's a lot more reasonable than the lunar surface temperature range, and thermal gradients, cycling, and fatigue should be less of an issue. However, it's still really cold, and it wouldn't be a bad idea to protect the habitats and equipment. Impactors are less of a threat on Mars than on Luna, but they're still a problem. The thin Martian atmosphere will take care of most of the really common small impactors. The larger stuff will still get through, however. I couldn't find data on impact rates, but I figure it will probably be about the same as on Luna for larger objects. Anything exposed on the surface for a long period of time, such as habitats and equipment, run the risk of being hit. So briefly, here's how I came up with SPORE. I was researching the possibility of using lunar iron to make habitat pressure hulls. I got to the point where I needed to figure out how to actually get the required iron from the lunar rocks. Like everyone else, I started looking at how to make surface regolith mining work, and my conclusion is that it's really difficult. Albert Einstein said, "A clever person solves a problem, a wise person avoids it." So instead of figuring out how to overcome these challenges, I started working on how to avoid or minimize them instead. And SPORE is what I landed on. So I've been using the term SPORE. Let's go ahead and define it. SPORE stands for shielded for most surface threats, pressurized oxygen which creates a habitable work environment, resource extraction, which results in less regolith dust and a better source of raw material. Additionally, the name SPORE works on another level. In biology, spores are structures used by organisms to survive in unfavorable environments. If SPORE works out, humans can use modified versions of it to thrive throughout the solar system. I found two very prevalent paradigms for Martian and lunar settlements. We either bury them under regolith or we leave them fully exposed on the surface. I honestly don't get the last one, given all the surface hazards. The typical solution is to protect settlements by piling up regolith on top of the habitats using teleoperated robots. There are some problems with this strategy, however. We need high-tech, reliable, regolith-moving robots. This is obviously a significant challenge since we've been working on this for decades and still don't have it completely solved. And pushing large amounts of regolith around is sure to make the dust problem worse. Of course, we don't have any experience with this, so we don't know just how bad it will get. And the proposed radiation shielding thickness is usually insufficient for permanent settlers. There's a lot of talk about career limits for radiation exposure, and that's fine if you're planning short stays. However, it's unacceptable for homesteaders that are going to spend the rest of their lives there, especially if children are involved. In addition, many of the challenges associated with Martian mining exist because the equipment and personnel are exposed to open space on the surface. The SPORE solution is to avoid the regolith as much as possible. Okay, obviously, I'm not an artist, so any artists out there that want to help should definitely contact me. I couldn't find data on the subsurface structure of Mars, so I'm just going to go with what I have for Luna. Mainly, I don't know if Mars has a mega regolith or if the regolith just sits on solid bedrock. What lunar homesteaders will do, however, is build the habitats and conduct mining activities in the mega regolith at least 10 meters below the surface. Why 10 meters? Because the median depth of the Mare regolith is about 4 meters. I couldn't find any data on the regolith depth for Mars, though. 10 meters will put us solidly into the mega regolith. If our homesteaders find 10 meters isn't deep enough for their site, then they go down 15 or 20. Whatever it takes to get past the regolith and its dust. Plus 10 meters should completely protect the habitats from all external radiation, as well as most impactors. And the known issues is just there to let you know that I'm aware of some of the disadvantages, or what is thought of as disadvantages. So let's talk about some of the advantages of SPORE shielding. We minimize dust interactions by going directly under it. We're not building on the regolith or pushing it around. Few operations actually need to be conducted on the surface. 10 or more meters of shielding will eliminate radiation as a concern for habitats and mining operations. Also, there's no need for radiation-hardened electronics. Surface temperature fluctuations are no longer a concern. Waste heat management is going to be a concern, but that's going to be true of any Martian or lunar habitat. Throwing a meter or two of regolith over a habitat will eliminate the threat by the small stuff that gets through the atmosphere. Obviously, thicker shielding material will provide better protection against larger impactors. It would take a 430 kilogram impactor, give or take, to punch through 10 meters of lunar regolith shielding. It should be about the same for Mars. Anyway, this would be a pretty rare occurrence. And an extra 8 meters of shielding may not be necessary until it is. People planning on living there permanently are going to want significant protection. And I'll cover this more in the resource extraction section, where impactors are a bigger threat to exposed mining equipment. Robots are difficult to design because they need to operate reliably in a challenging environment with no maintenance for a reasonable amount of time. This has proven to be a very high bar. And we could be waiting a long time for settlements if these robots are considered mandatory. And we don't need robots. Humans have been digging tunnels and creating underground structures for a very long time. We're actually pretty good at it. So now that we're underground and safe from most surface hazards, let's eliminate the threats in our new environment. Atmosphere and metal extraction processes are going to produce a lot of oxygen. Mars is basically an igneous planet, and basalt is the key to both lunar and Martian settlements. And here are just a few of the common Martian minerals that are being considered for oxygen and metal production. As you can see, a major component of these minerals is oxygen. So while we can use oxygen for life support and rocket propellant, we can also use it to make the SPORE work environment habitable. The SPORE solution is to pressurize the SPORE work environment with 100% oxygen at 48 kPa. And here's the reasoning behind that. It's 100% oxygen because some unknown and probably highly variable amount of gas is going to leak away through the exposed megaregolith mine face. We don't want to lose the expensive nitrogen in our habitat breathing gas, so we'll go with a cheaper pure oxygen. 48 kPa because I've defined a 78% nitrogen, 21% oxygen mix at 70 kPa as one standard lunar homestead atmosphere. Atmospheric pressure can be halved without risking decompression injury or needing to pre-breathe oxygen for hours. Half of 70 kPa is 35 kPa, which is about what was used for all of the Mercury, Gemini, and Apollo missions. So we know that people can deal with it for several weeks at a time if necessary. 48 kPa also gives us a solid safety margin if the pressure starts to fall faster than expected. Homesteaders can immediately retreat to the safety of the habitat. However, people in the SPORE working area won't directly breathe the atmosphere. They'll wear some sort of full face, full breathing gear to connect them to an air supply with an umbilical. But if there is a problem, homesteaders could survive in the work area long enough to get back to the habitat. A pressurized work area with a breathable atmosphere has several advantages. SPORE creates a habitable, if not comfortable, environment in the work area. The vacuum threat is minimized, so spacesuits are not necessary. At this pressure, homesteaders can also freely move between the SPORE work area and the habitat. Lunch and bio breaks won't require eating from a tube or adult diapers. I'm looking at you, spacesuits. Homesteaders can also quickly retreat to the habitat if something goes wrong. It's not just the regolith dust we need to worry about. Any mining operation is going to generate copious amounts of regular dust as well. We can still look into using electrostatic or magnetic techniques. They may work even better in a contained area, but with an actual atmosphere, we can explore other options such as air circulation and lunar or Martian-made filters. We can even use a water spray to remove dust from the air. It may get a little messy, but we might be able to recover almost all of it with clever planning. The equipment doesn't have to be designed for the surface environment. It doesn't have to deal with vacuum, radiation, and all that other stuff. Let's see, pressurized work area, breathable atmosphere, several advantages. SPORE creates a habitable work environment, so you don't need spacesuits because vacuum threat is minimized. Because the pressure difference is safe, homesteaders can move freely between the SPORE work area and the habitat without having to do pre-breathing or dealing with living in a spacesuit. And they can always retreat back to the habitat if something goes wrong. Dust mitigation, any mining operation is going to generate a lot of dust, so you have to worry about that as well as regolith dust. And we can look into other techniques besides electrostatic or magnetic techniques. They probably work better in a contained environment anyway. And we can look into like air circulation using Martian-made filters. And we can even look into using a water spray to remove dust from the air. It may get a little messy, but we could recover all of it with some clever planning. All right, so resource extraction. So this is what we're working towards. And I know this isn't a lunar mining, this is a lunar mining picture. I couldn't find a good Mars mining picture. But this is exactly the opposite of what I'm proposing. So the standard solution is basically open pit mining of the regolith using robots. The two biggest problems with this strategy are that it takes place on the surface and it actively engages with the regolith. As we've learned, the surface is a tough place for equipment and the regolith adds to the challenge. And it's also a dangerous place for people, which is why we're using robots in the first place. Unfortunately, robots that meet these demanding requirements just don't exist yet. And another problem with surface mining that I haven't addressed yet is the low gravity. On Earth, we rely on gravity to provide enough traction for earth-moving equipment to operate. It's Newton's third law. For every action, there is an equal and opposite reaction. A bulldozer pushes against the ground pushes back with equal and opposite force, but the bulldozer is really heavy, so the pushback has much less effect. This is a big problem on the moon with 1/6 gravity. On Mars, there's 38% the gravity of Earth, and therefore 38% the countering force. We'll have to greatly increase the mass of our machines, secure them to the surface somehow, or just be okay with them doing a lot less work. And all of these solutions come up with their own problems. The SPORE solution is to avoid all of this mess. Avoid the regolith, go straight for the mega regolith, and use people to do it, not complicated robots. I've already explained why going directly underground eliminates or minimizes most of the challenges associated with surface operations. By building the system around human miners instead of high-tech robots, we take a lot of the uncertainty, complexity, and expense out of the equation. Sure, we have to provide life support, food, and all the other stuff humans need to survive, but we're doing that anyway because we're creating a settlement and not a robot farm. And now we don't have to wait for the robot tech to advance, and homesteaders aren't relying on expensive tech that ties them to Earth. And SPORE can use human miners because the work environment will be a protected, habitable space. The final component of SPORE resource extraction is low-tech tools. These may not be the most efficient tools for the job, but they have several advantages, including lower power requirements, easier maintenance, and local manufacture. It's probably a lot easier to make a pickaxe out of Martian iron than a teleoperated mining robot. So let's look at some of the benefits of SPORE resource extraction. Safety again. Homestead miners are protected from regolith dust, radiation, vacuum, thermal extremes, and meteoroid impacts. They're also safer in general because they're working in a habitable environment and the habitat is literally meters away if anything goes wrong. And operating in an enclosed space might help with the low gravity. We may be able to temporarily secure the miners and mining equipment to the SPORE structure, allowing people and equipment to work more efficiently. Lunar regolith formation and evolution is a complex process driven by the completely random destruction and creation of material by impactors. And you throw in excavation and ballistic sedimentation of existing layers with the effects of solar and cosmic particles, and the end result is, and I quote from the Lunar Sourcebook, a regolith whose structure, stratigraphy, and history may vary widely, even between locations only a few meters apart. Now, I know very little about Martian regolith, but we've got a pretty big challenge if it's anything like lunar regolith. So instead of trying to design equipment to deal with this mess, SPORE avoids it by targeting the large blocks of basalt that we think are the primary components of the Mare mega regolith, or in this case, whatever is beneath the Martian regolith. Now, don't get me wrong, I'm not knocking the companies that make simulants. Simulating the Martian and lunar regolith is a tough challenge, and simulants are absolutely necessary for many applications. However, lunar, Martian, and Earth basalt are all physically and chemically similar. Bypassing the regolith and focusing on basalt bedrock ejecta of the mega regolith avoids a lot of complexity and uncertainty. How does creating habitable space while extracting resources sound? We can do that with SPORE. SPORE is a modified version of a tunneling shield. Tunneling shields were used first in 1825 to excavate the Thames Tunnel. They are used primarily for ground that is soft or unstable and protect workers from falling materials and cave-ins. The key feature is that as the excavation moves forward, a permanent structure is built to line and support the structure left behind. With SPORE, that structure will be the habitat pressure hull. When enough hull has been built, we'll seal it off, then presto, we have a potentially habitable space. Of course, we'll have to install the equipment necessary to actually make the space livable, but that's a whole other problem. My original idea was to use the iron we extract from basalt to make the pressure hull. That idea is still in the works, but I've also started looking into using the basalt itself as a pressure hull material, perhaps with cast basalt components. And for the future, who knows? Humans can build amazing things given enough time and motivation, maybe even large underground Martian cities. Some of the advantages of SPORE habitat creation are the habitats are immediately protected as they are built. We don't have to wait for robots to build up enough regolith on top of them to allow people in or risk inadequate shielding. Extracting the resources necessary to create the settlement and creating the settlement are the same activity. This should reduce the amount of equipment we need to ship from Earth. And we can even bypass the resource processing step by shipping habitat hull components from Earth if we want to speed up settlement construction. Tunneling shields, underground mining, and basalt processing are mature technologies. We just need to adapt them to the new environment. There's no need for teleoperated robotic regolith movers, Martian surface-rated 3D printers, inflatables, and other untried or undeveloped technologies. There are a few other advantages in addition to the ones I've mentioned already. So the simple version of this, the first one, is that rocket exhaust gases send loose regolith flying at high velocity, at least on the moon. It will probably be an issue on Mars as well. And it's not just dust. Some of these rocks can be pretty large depending on how powerful the rocket is. Obviously, fast-moving rocks are a threat to surface structures and equipment. And one of the rules of lunar homesteading is to place as much of the settlement underground as possible. SPORE can allow homesteaders to create a lot of underground space. Underground structures will not be affected by plume-propelled rocks. And I've also toyed with the idea of using SPORE to build subsurface landing pads. Rockets would land and then be moved into a habitable area for unloading and maintenance. Again, avoiding the regolith altogether. Lunar settlements will experience some significant seismic activity. I couldn't find any data on Mars quakes though. Again, I don't see why this wouldn't be an issue, especially if we place equipment and facilities on the surface. I'm not a civil engineer, but from the few articles I've read, it seems that surface structures are more affected because of the layers of soil they sit on. Structures tied into the bedrock, like skyscrapers, are better protected. Structures inside the bedrock are even more protected. It's unclear how homestead habitats embedded in the megaregolith will fare, but it's a safe guess they will be more protected than any surface structure as they will move with the material surrounding them. From excavation equipment to habitat pressure hulls, the more equipment homesteaders can build and maintain themselves, the better. The overall lower level of technology needed for SPORE should allow settlements to substantially reduce their need for equipment from Earth. And of course, we won't know how low-tech we go until we try. And the minimal visual impact, this may not seem like a big problem now, but we start getting large-scale open pit mining on the Martian surface, there could be significant public opposition. And rightly so. There's no reason to repeat our bad behavior on Earth, on Mars. Almost everything associated with lunar homesteading is underground, and the surface disturbance will be minimal. And finally, lunar and Martian settlement for everyone. It's the lunar homestead slogan, but what it really means is that anyone can help move space settlement technology and techniques forward. You don't need lots of money or an expensive lab. Helping us consolidate our knowledge base is a useful form of research and desperately needed. Conducting small-scale research projects in your home is feasible and useful. And space settlement isn't just for elite astronauts or select corporate employees. We're not going to create lunar, Martian, or solar civilizations by sending the chosen few on limited missions. Lunar Homestead is working to create the tech needed to enable anyone to carve out their destiny on the lunar or Martian frontier. So Lunar Homestead, that's my company. Website, lunarhomestead.com, has much more information on SPORE and other topics. You can also email me any questions or comments you might have. So thank you for your time, and I'll answer any questions you might have.
There's one question from John. What about using argon as a buffer gas to make pure oxygen unnecessary?
Well, argon's pretty rare on the moon, so that would be a difficult thing to do. I don't know about how common it is on Mars, but I think it's also pretty rare. The point of using oxygen is that we're going to have more oxygen than we know what to do with. Because almost all metal extraction is going to involve producing some kind of oxygen.
There's a few questions about using natural caverns or caves as habitats.
Yep, and that's something that maybe a more mature civilization could do. One, we don't have any ground truthing for these types of features, so we don't know, how big they are, what they're composed of, how structurally stable they are. But guaranteed, you start putting human activity inside them, and you will change their internal environment, which could reduce their stability. So a lot of research would need to be done before we could safely start moving into lava tubes or caves or something.
And there was a question about using CO2 to reduce the amount of oxygen.
Yeah, I mean, again, The whole thing is that the spore mine face is exposed megaregolith on the moon. For Mars, I'm still, like I said, I'm not sure exactly what lies beneath the regolith, if it's hard, full bedrock, or like the moon, it is a mixture of ejecta and fractured bedrock. But the point of using oxygen is that it's an easily replaceable gas, because you're going to get some leakage through that exposed rock face. And it's going to be really variable. I mean, you could be tooling along through solid rock and hit a pocket of, you know, like loose regolith, or maybe even a void. So you have to assume you're going to lose some of your operating atmosphere in the work area, and that's why oxygen is used, because it's easily replaceable. Now, if you have carbon dioxide or argon or a nitrogen oxygen mix, now you're losing your potentially expensive and rare breathing gas.
Okay. Thank you. This is the official end, but we'll leave the room open for another 10 or 15 minutes if you want to ask more questions.
Sure, I'll be here if anybody wants to ask questions or unmute their mics, or we can just have a general discussion, whatever anybody wants.
There seem to be a lot of questions about, you know, using a replacement to pure oxygen. I guess, what is the concern about just using oxygen? Do you understand that?
Well, there's one big concern, and that's fire. I haven't done a whole lot of research on the flammability of oxygen at 48 kPa, 100% oxygen at 48 kPa. That could be a problem, in which case, you know, just reduce it. And then, of course, then you got the thing about, you know, the pressure difference is now too great to just move freely back and forth between the habitat and the work area. So now you got to do some pre-breathing before you enter the work area. But any kind of atmosphere in the work area is going to be better than having vacuum, up to a point. You get to the Armstrong limit, where now you're going to have to wear a pressure suit. Then they kind of negate. Yeah, I see a lot of stuff about caves and oxygen being a fire risk, and that is something that needs to be researched.
From Attendeees, there's a question about, is there less dust or less loose regolith at higher altitudes?
Yeah, I couldn't tell you that for Mars. I'm not a Mars guy, so I don't know that. Yeah, on the moon, you get deeper regolith in the highlands because they're older. Mare are younger features, so they tend to be thinner. But with Mars, I don't know the answer to that. But even if you have less or more, I mean, it seems like any Martian dust inside your habitat's a bad idea.
Okay. So maybe we should shut the room, and follow-up questions could be done on Slack.
Yeah, I think so. I'll be on Slack in a minute, and definitely be willing to talk to you guys about anything.
Okay.
Thanks, everyone. I appreciate it.